everyone, welcome to org analysis. So this is our concepts through problem solving part. Now here I am taking a question. The question was asked in CSIR-June 2019 for 4 marks. Okay, so the question is given. You have given a substrate, a kind of aldehyde, and you have this kind of methyl acrylate derivative, and this in DAPCO and PN-NH2. The PN is just benzyl group. Okay, so to solve this question, you have to know of important name reaction, that is Baylis-Hillman reaction. Okay, so now see, what is Baylis-Hillman reaction? What type of reagent is used for this name reaction, specific name reaction? Okay, so I am discussing over here for all those concepts related to this Baylis-Hillman reaction. Now let's start. Now before going to solving this question, we have to know the basic Baylis-Hillman reaction and the general rules, not rules actually, just general possibility and mechanism, and what the reagent and what the substrate are used and how the product formed. Okay, so let's start the Baylis-Hillman reaction. Okay, now see, for Baylis-Hillman reaction, the things which is used for the substrate, used as a substrate, is a kind of aldehyde, and you have to take a acrylate derivative, that is ethyl acrylate. I am taking over here, and the influence of DAPCO. Now see, what is DAPCO? DAPCO is nothing but a tertiary amine. Okay, so you have to know that for this Baylis-Hillman reaction, the reagent which is used is a tertiary amine. Okay, I'm written over here, the reagent which is used for this Baylis-Hillman reaction is tertiary amine. Okay, so this tertiary amine is in most of the cases, DAPCO is basically used for this type of reaction, or maybe uses quinacridine. It's also a large, bulkier and tertiary amine base, or maybe some cases trialkyl phosphine also used. Okay, so these types of this is not tertiary amine, this is your trialkyl phosphine derivative. Okay, now these two are your tertiary amine. Okay, so this type of reagent which is used for this Baylis-Hillman reaction. Now see, what is the name of DAPCO and what is the structure of DAPCO? So the structure is this. Now this is the structure of DAPCO. Okay, what is the name and what is the full form of DAPCO? And the full form of DAPCO is 1,4-diaza bicyclo 2,2,2 octane. I think you have, or you may know the naming of this compound. Now see how to naming of this compound. The naming is nothing but there is a numbering from here: 1, 2, 3, and 4, and 5, and 6, and 7, and 8. This is a 8 carbon, and numbering from here, and 1 or 4. This is 2 as a compound, that is nitrogen based compound. That is why it is 1,4-diaza, and the naming is this type of compound is generally called bicyclo compound. And the 2,2,2 is means from this nitrogen to this nitrogen, how much carbon you have to pass. That is this 1, 2. Here you have 1, 2, and here you also 1, 2. So that is why this 2, 2, 2, and you have 8 carbon over here. So that is why it's octane. Okay, so that is the overall naming of this 1,4-diaza bicyclo, that is DAPCO. Now see, this type of Baylis-Hillman reaction generally follows the Michael addition pathway and of the alpha beta unsaturated ketone or esters. Okay, so that is alpha beta Michael addition at alpha beta unsaturated ketones or esters. Okay, so now see, now we have taken this compound, and we will solve this question and go and also know now how the reaction proceed and how this all over things happen. Now see, I am written over here, and this is also the general mechanism. Okay, mechanism. Sorry. Okay, so this is a mechanism. Now see, I am taking compound of this which is given to you, that is this is methyl acrylate. So I'm written over here, that is CH2 CH, say double bond O, and your OMe. Okay, now the base, what is the role of this base now? Okay, so nitrogen has a lone pair of electron, so it this type of reagent generally attacks to this ketone as a 1 alpha beta unsaturated ketone as in via this Michael addition pathway. Okay, now see, when this bond is attached with this, now this is your positive center. Now you have the CH2 unit and your CH, here is your double bond, here your O minus, and here is your OMe. Okay, now this bond and this bond generally tries to go back over here, and this double bond will attack over the aldehyde center which we have given to the substrate, that is this type of aldehyde. Okay, now this is your aldehyde, this is your Cl, and this is your F. Okay, now these bonds go here, and this will attack over this here, and these bonds go up. Okay, so now see, now you have your compound like this. This is your O minus, and you have your, here is the hydrogen actually. Now you have your CO2 Me, here this CH2, and this is your nitrogen part, that is your nitrogen written over here like this. This is your positive charge. Okay, so that is how it is formed. Now see, this now after that, this is your acidic hydrogen. This is your acidic hydrogen. This is just because of this adjacent to this ester group. So this acidic hydrogen is abstracted by this DAPCO. I am not written the overall structure, I have written this tertiary amine like this. Okay, that is R3N. Now this R part is overall DAPCO, that is nitrogen over here, and this part is abstracted from here, and here is your negative charge. Okay, so this negative charge is just nothing but here it will conjugate like this. Okay, so your product of after the abstraction of this hydrogen, your product is look like this. Your O minus, here is your OMe, and this is your overall part, this is your positive. Now these bonds go over here, these bonds go here, and this will leave from the system as a free. Now the uses of this tertiary amine is just because of it will regenerate to form it will regenerate, and it can be used after the overall free actions also, just because of it is recyclable. Just because you can see you have taken a free tertiary amine, that is DAPCO, and this DAPCO is generally simultaneously free from this side. Okay, so this will free from reaction. Okay, so now after that you get the structure like this, and this is your O minus, this is your double bond. Now this is your double bond, this is your product. Now see, this is your this step, this R3N, that is DAPCO. This will take a proton from here. Now this will be protonated from. Now I am written the overall structure, that is sorry this one. Okay, so this will takes a proton, that is positive center. Now this O minus takes a proton from here, and this will free. Okay, so your product looks like, that is your OH, it's a double bond, that is your CO2 Me. Okay, now there is a F and your Cl. That is how this is a double bond, and that is how this product is formed. Now see, now in this is your ultimate product of Baylis-Hillman reaction. Now this is the overall mechanism also, the Baylis-Hillman reaction. Now you have given the second reagent, that is BNH2. BN is nothing but the benzyl group. Now this is a kind of nucleophilic attack, that is nitrogen lone pair of the nitrogen over here, and this will attack to the center, and actually this is written over here, this is your negative charge. Okay, now see, this is your OH, and now here is your negative charge. This negative charge is conjugated to this system, and you have your NH, your BN, your hydrogen, and this is your positive charge. Now this will take a proton from here, that is minus of H plus and plus of H plus. So this proton, after that, this proton abstraction, you get here is your F and Cl and F, and that is how you get your final answer, NHBN, and this is your CO2Me. Okay, now this is your final product. Now see and check the options, that the options is given like this one, this one, and this one, and this one. Now see, this is your final product, that is A is your correct answer. And now see the other options which is given to you, that is this is double bond is here, this nitrogen lone pair will attack on this ester group, so this will not happen, so it generally attacks to this double bond. We have already seen that. And now this OH will not leave from the system just because of this PNH2 will directly attack to the double bond, and this has no possibility of this formation. So that is why this option A is your correct answer. Okay, so now this double bond is much more susceptible to nucleophilic attack by this any kind of reagent. Now I am taking a few compounds which is the extension of Baylis-Hillman reaction and examples of Baylis-Hillman, which is also important for your exam purpose. Now see, I am taking compound like this. That is your aldehyde, and here is your OH. And if you add this type of compound, R is nothing but your kind of any esters or CO2Me or CO2et like that. Now if you use in presence of DAPCO, so you get you all know what will be our product. Now see, our product should be like this. Here is your OH, it's a double bond, this is your R. So you all know this is our product. Now after that, there is a possibility of this adjacent oxygen atom, this will attack on this system, and this bonds will go over here. Okay, so, and it is a minus of H plus, and so plus of H plus. We know what will be our product. Our product is look like OH, this is your R. Okay, so that is our product. That is now see, there is a chance of leaving of this H and OH like this. So minus of water, we get our desired product. Okay, so that is how this product is formed. So this is one kind of extension, that is, and it also tells us that this like lone pair of electron always attacks of this free double bond alkene. Okay, so that is why this double bond is more approachable to attack for any kind of substance. Now I am taking another example which is also important for you, that here is your aldehyde and here is your OR, there is any kind of esters R group. Okay, so if we use CO2Me on the system, and generally that is DAPCO, the base which is used in Baylis-Hillman reaction. So now our product is your OH, this is our product, and this is our RO. Okay, now in the medium of this medium, you can if we use this acetic acid, ACCl, that is acetyl chloride, ACCl in presence of pyridine. So what the pyridine will work, how the pyridine in presence of acetyl chloride, that is pyridine will abstract a proton from here, and this O minus will attack on the AC, and Cl will leave from the system. So our product looks like this is our product. Okay, so CO2Me, this is our OR. Now if we use sodium borohydride, NaBH4, sodium borohydride in methanol. So now if we use the sodium borohydride in methanol, now how the reaction works, this hydride will attack over here So see, these all the example tells us that this hydride or this any kind of nucleophile always attack to this alkene. So this is our CO2Me and this is RO. Now after that, if we use KOH in presence of any methanol, that is hydrolysis of the ester group which takes place. So we get our desired product like CO2H over here, and this is our hydrogen. Okay, so that is how this overall reaction proceed. Now this is all example, and this is almost enough for your exams also. Now this Baylis-Hillman reaction is very much important for your exam, and the question is also asked for 4 marks. So I hope this video is useful for you, and I think I will cover all those topics related to this name reaction. And if you interested and if you find this video useful, you can share it with your friends, and please subscribe my channel. And thank you so much for this. Thank you so much for watching.